guys, welcome to ANK Resource World. Your success, our motto. If you have not subscribed our channel, please do subscribe. In this video, we are going to learn about the capacitor filter as well as the choke filter, which is used for reducing the ripple content, the AC content from the output of an rectifier circuit. Okay, here we are going to learn about the capacitor filter as well as the choke filter, which are used for reducing the AC content, nothing but the ripples from the output of a rectifier circuit. So as we have already gone through different rectifier circuits, we have seen that the output of a rectifier is not pure DC, it contains some AC component and we need to filter that. So for that we have some simple filter which is known as capacitor filter, and we can also make use of a choke filter where an LC circuit is followed by the capacitor. Okay, let us have a discussion on this. Okay, let us learn this. You can see here this is our capacitor filter. Here a capacitor is connected across the load resistance RL, and what is the input given for this? It is actually the output of the rectifier circuit. See the output of the rectifier, it may be a half wave rectifier or it may be a full wave rectifier, right? So now how this capacitor filter works here and how it's going to remove the ripples from the output of the rectifier, which has the AC component. You can see here we have this dotted line, that is positive half cycles. Actually that is the output of the full wave rectifier, what we have discussed and learned in full wave rectifier circuit, right? Yeah. So now you can see here if the rectifier output, that is the output here, if the rectifier output is greater than VC, that means the voltage drop across the capacitor. If the rectifier output is greater than this VC, then this capacitor charges. You can see here during the time period T1, from here to here, the VC, that is the rectifier output, is more than VC. Therefore, during this time period, that is T1, during this duration the capacitor gets charges. Okay, so once it gets charges, after that slowly we can observe the output is falling. Sinusoidally the output is falling. When the output starts falling, when the output of the rectifier becomes less than VC, that is the voltage across the capacitor, then this capacitor starts discharging. Okay, so that means here the capacitor charges and discharges by reducing the ripples at the output of the rectifier. So you can see here the output, what we get, charge, discharge, that is charge, discharge, charge, discharge. So the output what we are getting, it is almost approximated to a straight line, which shows that it has almost a negligible ripple, and we can say this is a kind of filtered output which is a pure DC with negligible AC content in this output. Okay, so this is how a simple capacitor filter works, and we know that the ripple factor already we have calculated for full wave rectifier, okay, as well as we have calculated for this half wave rectifier, and the ripple factor has to get reduced after using this capacitor filter. So therefore the formula for the ripple factor gets modified, gets changed, and you can see that here with the ripple factor can be calculated with this formula, that is R equals 1 by 2 root 3 RL into C. So where RL is our load resistance, and this formula can be used for half wave rectifier with capacitor filter. So if you want to calculate the ripple factor for a full wave rectifier, then we can use this formula with capacitor filter. Okay, so this formulas will give you the reduced ripple factor after adding this capacitor filter to the output of the rectifier circuit. And also VDC can be computed here for this capacitor filter circuit by using this equation, that is Vm the peak voltage at the rectifier output, that is Vm maximum voltage minus half of V ripple voltage. Okay, so now let us see here how this choke filter works. See here, we are combining the capacitor with the inductor. Actually here an LC circuit is followed by this capacitor C1, where the capacitor C1 charges to the peak voltage of the input, that is the rectifier output, and this inductor starts opposing any sudden fluctuations or changes, because already we know that an inductor opposes AC and allows DC. So any sudden changes or fluctuations will be opposed by this inductor, so which in turn reduces the ripple and which will give that voltage to this capacitor C2, ripple reduced voltage to C2, which will further reduce the ripples and give the constant output DC voltage across the load resistance. So this is how this simple choke filter works, as well as the capacitor filter works, and we use these filters to remove the AC content from the output of the rectifier circuits. Guys, keep watching our videos. We will be bringing more such videos relevant to your topic of interest. AMK Resource World, your success, our motto.